Hello, this time I'm going to cover copy constructor and why it is important if we are using dynamic memory. So let's create one class called person. So this is our class, and let's have some public data for this. For this, let's keep it short and string, and this time I'm going to keep this string in this is the name in dynamic memory. And another one, integer, let's say ID, social security number we can say also, and this is in the stack we will create. So at this time, when I have this one, and let me create one, let's make this all of them private, and create a constructor for us. Let's create a public, and this is the default constructor or two parameter constructor. Let's pass string name and integer social security number like this. So that's our constructor. Integer string, what is it's going on? Maybe I will say using include string. Oh, I got it. Person constructor. Sorry about that. So I created a person constructor now, and I need to set, right? If I create an instance over here in my main, which is the client, right? So if I create a person, let's say Mike. Okay, I need to pass Mike's name. Let's say Mike and social security number. This is just number for now. 11. So when I come here, I will be doing this. For the name, for this name, I am using the same name. Let me not confuse you so much. I will say a name. This is a string, not a pointer. So firstly, I need to allocate memory location for the string, and then later on, I will just use this indirection operator, name equal to whatever the name is given to that location. And then what I will be doing here, I will just social security number. Let's use this time. So this social security number equals social security number. As you know, this pointer is, I am separating this from the social security number. I mean this implicit pointer to the object itself. So what's happening in the memory? Let's see what is happening. As you know, there are two types of memory. One is static memory, the other one is dynamic memory, like this. And when I did this, Mike object is created in the stack, like this, somewhere in the stack. So we have a string, as you know, the pointer, which can only hold an address of string. The other one is, I'm going to put like a real letter, this number. So this first one is the pointer. Oh, this is so big. Let's have 16. So go back and come back here. This is just a pointer, name pointer. The other one is social security number and real integer. So the 111 is going to be held over here. In this one, we create a dynamic memory like this. I mean, this is for string, maybe like this. And we put Mike inside. This is the Mike, the string. We just put this, whatever this string passed, here a string, and we put with indirection operator. So we put over here Mike. And I'm just going to use this notation. Here we have an address for this Mike in the dynamic memory. I'm showing this way. So this is, let's say, dynamic 01 location. This is holding only the address. This is a pointer 01. But this is all well. This is nice. But if I want to create another person, for example, this time it's Dan, and I would like to pass Mike to it. Okay. If I don't create copy constructor, this is going to call copy constructor. And another notation is this, like this is, both of them are equivalent. So let me use the other one, which is more obvious. So what is going to happen when I create Mike now? Let's see what's happening when I create Dan out of Mike's data. So compiler will create another memory location for Dan like this. Okay, Dan has two data, again same like sort of name of Dan and for Dan's social security number. Compiler memory-wise copy it will make. Take this 111 to over here, 111, and also D01 to here. So what happened? It didn't allocate any memory location. So these two are showing to this memory location. Got it? So if I ask the name of the Dan, let's make this for now public, so we don't need to use so much bureaucracy now. For demonstration's sake, if I say Dan dot name, it will say first time Mike, right? Because we know we are just copied from Mike. So of course this is pointing just the address. This is good actually because I didn't use indirection operator. Let me also do this, and I am going to print. Let's first print the Mike's address and Dan's address name, because the name was a pointer, right? So run again. You see they are showing the same memory location. Actually it is D01 I said, but they are the same memory location. So if I want to print the value what they are holding, I just need to put here star, right? So to access the this memory location, this one, yeah, and when you run it, you will see Mike. That's normal. But if I come and here update Dan's name, Dan dot name, and I put here star, which is equal to Dan's name is Dan. Okay, so when I print, you will see in a second both of them are Dan, because I have single memory location and this is gone and Dan came here. That is an issue, because the default copy constructor is not doing the job right. So when I come here, what I would do is I'll create my own copy constructor person. I will pass another person. Let me say again lowercase person, and this time I need to use reference, otherwise copy constructor will be called again when I'm passing into the constructor. This one I can make constant here, so I promise I'm not going to change the person you give. So the data the Mike gives, I'm not going to change. So I'm going to create this and save. And if you, as you know, the social security number is on the stack, so I don't need to do anything for that. If I want to update the social security number is equal to given person's social security number. Okay, that's all set. But if I want to update the name, firstly I need to say name equal to new name. So by this, what I have done is I created another name location like this. Okay, I got the address. Let's say this is D02, the dynamic like 02. So it's put over here. Oops, I should be saying string again. Today is a little bit, we are making a mistake. String. So, and then what I'm going to do is I'll use the indirection operator name equal to star. Again, I need to use person's name dot name. But in this case, maybe if you want to do it, you may want to do like this. That would be better. And because person is not a pointer, I'm accessing and the data in name. So this time it will be after changing Dan's name, you will see only change in Dan's name, not the Mike's name. So let's run it. Yeah, Mike stays Mike. If you look at, memory addresses are different. 40, this one, F0, 40 here, F0, and Mike stays in the Mike, Dan stays in the Dan. So it is exactly like this. So this is the address, D01. This is the address for this guy. And when I put the Mike, Mike goes into Mike, Dan goes into Dan. So no confusion. This is so important. As you know, even though my there's some maybe wrong assumption, even though it is in static, and these are all in static memory. If you look at it, I'm not using new person, new Dan, or I mean new pointer, but they have some partially created on the dynamic memory. So that is really important. What is missing in this one? I need to have the constructor, okay, this person, because if you use new, it is your responsibility to delete. So in order not to have memory leak, I need to come here, and when I'm done, I should say delete name, because the pointer. Maybe from the very beginning, I should rename this to pointer to name. Then that would be much better if I do this. So everything much clearer now. Hope this is clear now. So what we have done is we created a person class. It has two data member. One of them is in the dynamic memory, like this here. The other one is on the stack when we create. So in this model. So we want to make sure when we are copying from other object, creating Dan out of Mike, so we will point to the same location unless we have copy constructor. Copy constructor is nothing, but it takes another object which is the same type as you look at person. This is person. So we are getting data out of them. So for this case, in order not to make mistake, we allocate our memory like this, then set the data. In C++, if you don't have this, actually computer creates this pointer to name equal to person dot pointer to name. So what it does is it copies the 01 directly here. That is not what we want. So we would like to use this. This is wrong. Let me put here. This is wrong. And this is the way you firstly allocate new memory location for yourself, like this, and you change this to, I should be doing this. This is gone. New one is D02. So everybody has its own memory location. This is now pointing here, not to this one. So everybody is now free from each other. So when I create Markdown, and so I created Destructor. In this case, I don't call the delete because I didn't allocate anything in the memory in main. This is client, as you know. This is my responsibility if I'm making this person class. So you may say, why don't you call the delete? If I made something like this, like person Murad, but this time pointer Murad, and equal to new person, and I passed the Dan this time. If I do this, what will happen? I created the Murad on this side, okay, like this. Murad is like this. It has a pointer to a name and also and social security number. So for this one, when we come here, it creates another new memory location here. This is for the name. So actually this guy is pointing to this one. Maybe I should have used different color. This guy is pointing to this one. So this is holding only address, like here name, pointer to name. The social security number will be here. So all of them dynamic memory. So this is not my responsibility if I'm the developer of this main is the client, as you know. I need to do when I'm done ptr murad. So what's gonna happen when I do this, it will call the Destructor to free this memory location that I created, or this one. I'm sorry, this one. So if you for the Mike and Dan is only their lifetime is valid between this curly bracket, so they should be all set. Thank you. That's all. Bye.